Hello, welcome back to Learn Physics. In today's topic, we are continuing with our sound chapter. Okay, in last video we finished the characteristics of sound waves and the waves, how it will be moving in the medium, that and all we discussed, isn't it? So today we are going to study about the reflection of sound wave. So till now we learned about the propagation of sound wave and how it is propagating. All those things we learned, isn't it? Now we are going to study about the reflection of sound. Sound is going to towards the medium, reaching to one point and reflecting back. It's coming back. So the sound wave, when it is coming back, reflection, that is called as echo. So echo is the sound reflection of sound wave. That is called echo. If echo is the reflection of sound wave, see, I am teaching in this room. So while I am teaching, these sides and the opposite side and back side, everything, walls are there. Why that reflection is not coming as an echo here? The reason is many objects are here to attract the sound waves or to absorb the sound wave. Many objects are here. So they will be absorbing the sound waves. So the amount of echo will be less over there. Okay, and one more thing, see, if we hear one sound for 0.1 second, it will be there in our brain itself. Okay, so we know in the eyes also having that while we are seeing one object for a particular time interval, we can see the object, isn't it? Persistence of vision. The same way here also, after 0.1 second only, it will go out from our brain, that sound wave. So the reflected wave is coming to our ears is before this 0.1 second, we won't identify or recognize it as an echo. Okay, so actually the sound wave is going and reflecting and coming back to our ears, but we are not recognizing that as a reflection. Why? Because for 0.1 second it will be there in our brain. Okay, after 0.1 second, if it is reaching to our ears, then only we will be identifying it as an echo. Echo is the reflection of sound wave when it is reaching to our ears after 0.1 second. Okay, so what will be the minimum distance required to hear this echo? Minimum distance required to hear for echo. How we can find out the minimum distance? So distance, how we can find out the distance? Velocity equals distance traveled divided by time, isn't it? So distance, if we want to calculate, we should calculate the velocity into time. What is the velocity of the sound wave in normal temperature? Yes, it is 344 meter per second into 0.1. So velocity of sound in normal temperature is 344 meter per second. So we will get here as 34.4 meter. This 34.4 meter means, see, if the source is over here and the reflector is over here, okay, then the sound wave will be going and will be coming back in 34.4 meter. So what will be the minimum distance it is required? Minimum distance required is half of this one, isn't it? Minimum distance equals 34.4 divided by 2, that is 17.2 meters. So minimum of 17.2 meter is required, or more than that also can happen. Okay, more than that also we can hear the echo, and the temperature should be the normal temperature. If temperature is decreasing or increasing, according to that the value, slight variation in values will be there. Okay, so clear all of you how we can find out the minimum distance to hear echo and what is meant by echo? Clear? So next we are going to study about reverberation. Reverberation means multiple reflection of sound wave. That is called a reverberation. Reverberation means, see, echo will be repeatedly hearing. That multiple reflection. Reflection will be happening multiple times. That is called as reverberation. Next we are going to study about reverberation. Reverberation is the multiple reflection of sound wave. Reverberation is the multiple reflection. Multiple reflection of sound wave, when it is happening, this multiple reflection, see this, suppose I am considering the megaphone while I am considering, see, this is the source. From here only we will be giving the sound waves, isn't it? So it will be reaching here, reflecting and will be going. It will be reaching here, reflecting and will be going. So it will be reaching to many number of people and to a large wide extent it will be going, isn't it? So this is the one of the uses of this multiple reflection or reverberation. Okay, second one is stethoscope. In stethoscope, how it will be working? Stethoscope means it will be, see, like this we know. It will be like this, isn't it? So here the doctors will be, from here the heartbeat will be going and it will be getting multiple reflection and it will be reaching to the ears of doctor. So this is here it is stethoscope also we are using multiple reflection. And next is in concert halls. Concert halls we know it is reflectors will be there, isn't it? Very good. Reflectors will be, even the roof also will be sound reflecting surface will be there. See, from here the sound wave will be reaching to this portion and will be getting reflected. So sound wave which is reaching here and it can reach to many number of people, isn't it? So sound reflection will be there because of that reflectors. And then sound boards will be there. What is that sound boards? Sound boards means, see, source will be here, sound source will be here, and here it will be sound board and it will be reaching to this point and it will be getting reflected. So this is another use for this reverberation. Okay, clear? So these are the portions where we are using multiple reflection. Okay, next we are going to study about the range of hearing. So range of hearing is mainly between 20 Hertz and 20 kilohertz. So next is range of hearing. Range of hearing. Range of hearing is mainly between, for a human being, while we are considering, the range of hearing is between 20 Hertz and 20 kilohertz. Okay, but below 20 Hertz, children below 5 years can hear this 20 Hertz. Less than 20 Hertz, children below 5 years can hear clearly, and some animals also can hear this below 20 Hertz very clearly. So this below 20 Hertz are called as infrasonic sound wave. Infrasonic sound wave. And even rhinos will be talking between below 5 Hertz. They will be talking in 5 Hertz, and others, elephants also will be talking in this below 20 Hertz only. But some animals will be there, some birds like bats and all will be talking in above 20 kilohertz. above 20 kilohertz. Bats will be talking in above 20 kilohertz. So they will be their sound and all we won't be hearing. They will be making a noise. They will be producing some sound wave which is above 20 kilohertz, and when it is going to that other person, if some obstruction is there in between while they are flying, what it will do? It will be producing this sound wave which is above 20 kilohertz, and it will be reaching to the obstruction and will be reflecting and coming back to them. So they can identify whether any obstacle is there. Even they will identify the prey in such a manner. Okay, even porpoise will be doing the same thing. The porpoise also will be producing a sound wave, and they can hear the sound wave which is greater than 20 kilohertz. So the frequencies which are above 20 kilohertz are called as ultrasonic sound wave. Ultrasonic sound wave. They will say it as ultrasonic sound wave. Okay, clear? So I'm winding up for today, and I hope all of you understood all those things. In today's topic we covered this reflection of sound wave. That is, first one, echo. Minimum 17.2 meters is required to hear the echo. Then next we learned about the reverberation, and next about the range of hearing. Okay, clear all of you? So if you like the channel, please don't forget to subscribe. Thank you for watching. Bye.